So our next topic is we will dive into the strategies of DevSecOps by exploring how to maintain a balance between security and our developer productivity, from preventing burnouts and ultimately ensuring long-term success. So I welcome Ram Iyengar, Chief Evangelist of from Linux Foundation, to discuss whether a shift left or swipe left approach is more effective.
Hello, everyone. Very good afternoon to all of you. I know the session after lunch can be the most difficult one, not just for the person who's giving it, but for the people who are listening to it. But that's the difficult thing about putting together a good conference. You have to make sure lunch is great, but not so great that people eat and sleep off. Anyhow, welcome to my talk. My name is Ram. I am the chief evangelist of an open source project known as Cloud Foundry. I also assist the Linux Foundation on another project known as the OpenSSF. And what I'm going to talk about today is sort of some lessons I picked up along the way, working with both an open source community and then the security community. Now, the title of my talk comes from this popular verb these days. I mean, all the kids are doing it. I'm not doing it, promise. But it's like how we've replaced I'm going to web search for something with I'm going to Google something. I'm going to, nobody says, I mean, I don't want to offend anybody, but nobody says I'm going to Bing something. So, so much like that, if you don't like something, the word you use these days is to swipe left on it. And maybe we can ask some of the younger kids why that is and things like that. But the real title of my talk today is DevOps versus DevSecOps. Now, I'm going to start with a small marketing story. I know a marketing story is somewhat out of place in a developer conference full of engineering audiences and things like that. But I think this is a good story to tell at this place. Now, in the beginning, when some of us, I think I can see some of the audience can somewhat relate with this. There was dev. We all used to program stuff, and it used to be shipped on CDs. Now, there are some people in the audience who don't know what a CD is, which is good. And then what happened was a lot of the software that we produced and published moved online and to this thing known as the cloud. And then that gave rise to a new sort of profession called ops or operations, where you basically had to keep a piece of software live so that it could be accessed via the internet by the public. And eventually what happened was the people that were writing the software started to become the people who had to keep it running online. And so it sort of started coming together, and people's responsibilities, expanded. And it was not about co-locating these teams or having the same responsibilities split into a few different people and things like that. But then it sort of fused into this new kind of developer persona that we all love to call as DevOps today. And then while we were all busy becoming agile and DevOps and platform and all of these things, somebody convinced us that, hey, you need to take into account security as well. And that really gave rise to what is, now culturally being referred to as DevSecOps. But I have a bit of an opinion and a problem with that, which I'll get into in a little bit. What it really means is take into account security from the time you start developing a piece of software, as it goes through the process of getting built and packaged and deployed, and continue to maintain a sense of security when it is on production. Somehow, these people marketed the idea that security is a very big part of DevOps. And they somehow infused the sense that, oh, if I'm an engineer today, I need to be able to take care of so many things, and security is a part of it. The truth is, teams are struggling. Teams already have so many different things to take care of right now that they're struggling because of the way security processes are traditionally designed in our company. And I'll give you an example without alienating any of the speakers who spoke before me or some of those who might speak after me. Because my experience with security has been, I'm working towards the release, I have a date in mind, I have my user stories, I have my list of features, I'm just knocking them out, I'm using Golang and TypeScript and all of these new tools and technologies that have really just come into the market. And then all of a sudden, just as I'm about to release or just as my automated pipeline is about to release the features that I so lovingly built, somebody comes and says, hey, we conducted a security audit on the code that you have put out. This image that you're actually trying to deploy has like 14 different CVEs, and so it cannot be deployed, and so what you've written cannot go to production as planned. So this is my experience with a security team. Now, some of you might relate to this. Some of you might work in companies where this doesn't happen, not because you write good code, but because security practices don't exist. I mean, either ways, I'm a little jealous. But the point I'm trying to make is the traditional roles of developers or DevOps and security is at a tug of war with each other, because as developers, we're always aiming for, let's build it, let's ship it, let's build it, let's ship it. So everybody is obsessed with velocity. And there's nobody to blame here. Even this whole massive ecosystem of Kubernetes and cloud native and all of these things, they're all designed to help you build software and push it out to production as fast as you can. They're not designed to say, hey, stop, think about it. Do you want this stuff to go into production? Is this secure? Do you know if this is good enough in terms of not having enough vulnerabilities or not introducing a lot of errors and things like that? And so there isn't an innate culture of security that developers have by nature. And so we always are forced to deal with these problems at the last minute, and then releases get delayed, and then there's backlogs and things like that. And how do you decide that there's a problem with the image that is being deployed versus there's no problem when the same image that was built like days ago on like a pre-production server, or when I was doing some testing on my own machine and things like that? So why is it okay for CVEs to exist in my images between the time I write the code until it is getting ready to be deployed to production, but it's not okay to have them in production? So those are the kind of problems that I really want to talk about today. And I just don't want to cause a ruckus and leave and then leave you without solutions. I'm going to show you a few very short demos that will actually show you and illustrate what some of these solutions can look like, and some very basic steps that all of us as a community of developers and as a big community of programmers can start to adopt. Some of us go by the term DevOps engineer. Some of us might go with the term platform engineer. Some of us might go by SRE. Some of us might be senior principal software architect, blah, blah, blah. It doesn't matter. The idea behind this talk and some of the takeaways that I have are to inculcate a small sense of, okay, I can take these small steps that Ram showed in Kochi that day, so that some of the things I do is more secure. So for my first demo, what we're going to do is we're going to create container images in two different ways, which you're probably very familiar with. And those two ways are going to just demonstrate how much easier it is to create something that's more secure versus less secure. The first thing I'm doing is, most people can see this, right? If you can't, they're recording it. You can go back home and watch me again. But what we're doing here is something very simple, where we have a Docker file that creates a build of a Golang application. So there's a teeny tiny application that's written in Go that I have, and it has a Docker file, and then this process is just building from that Docker file. So you probably recognize a lot of the steps. So it's downloading the Golang image itself, it's doing the build, and then it's doing a multi-stage build, because It's a better way to construct that image. And finally, it builds using this base image as Ubuntu Jammy, which is the latest LTS version. What I'm doing next is using a tool called Gripe. What Gripe will do is, it's an open source container, it's an open source security scanning tool. In this case, I'm using it to scan the image that we just built. And if you look at the image, it's got all these different CVEs. Now, for those who don't know what a CVE is, it's a vulnerability. It means it's bad, okay? CVE equals bad. So you cannot ship, technically, you're not supposed to ship with a vulnerability inside your image. Now, without raising your hands, do a silent self-introspective evaluation of how many people are actually shipping their applications using Ubuntu Jammy. Don't raise your hands. Your manager might be in the audience. The point I'm trying to make is, you're shipping with so many different CVEs in your images, you're probably not even aware of it. How hard is it to get an open source tool and add this check the minute you build an image? Not hard at all. Why don't we do it? Because we are not aware of it. Also, we don't want to get caught. Now, the other part of this demo is where I swap out Jammy for this other image known as Wolfie. Okay, so Wolfie is an image maintained by a community of security professionals at this company called ChainGuard. But what they're trying to do is to create low CVE, that is very few vulnerabilities, or zero vulnerability images. Now, they have images that are specific for every language family, but they also have images that are functioning as a whole operating system. So in this case, I'm using Wolfie to build the image. And what you'll see when I scan this is 3 CVEs opposed to 45 that was there before. And so by just swapping out one base image for another, you can gain so much mileage in terms of securing your application. Like I said, CVE, bad. Low CVE, good. No CVE, great, amazing. But the idea is, we push towards a world where, there's no CVEs, but we all know that it's kind of, impossible, and it's only possible in theory, not in practice, but we can drive down the number of CVEs as much as possible, and that's something not beyond all of us. So 2 takeaways from this demo: swap out your base images for better base images that are available, and try to include some kind of code scanning when you're building images before you ship them off and things like that. So first part. Now, the big question that I always get asked is, Ram, what you're showing is fine. We really like it. It's probably very easy to automate, but is this even possible to do? And the question arises because there's so many parts that are really inside. When you take apart this whole process of creating software, there's so many different things that a developer has to do. And we're trying to introduce another one. But my big complaint is, developers are okay with doing all of these things on the left, but they don't want to do that one extra thing. Just when I say include a few security automation tools, everybody has a problem with it, but they want to integrate Grafana, they want to integrate with open telemetry tools, they want some Prometheus that's pulling metrics from somewhere. They're very happy putting all these fancy tools about networking, and so it's really beyond me why developers are happy with one set of tools and embracing one kind of complexity, but they really shun another kind of complexity when it tends to add a lot of value. They're already juggling so many different things. I know. I have been a developer who has done all of that. But it's not very difficult. And so the big thing that I want to emphasize on stage is also the fact that introducing DevSecOps is not just about adopting or buying new tools. It's not just about saying, hey, let's do scanning, let's do new images, let's introduce fuzzing and all of these things. It's also a bit of a cultural shift. People need to understand that this is a people problem. It's not just a technology problem, and people need to be convinced to say, admit at least that, yes, we could do something better in terms of securing our processes and workflows, and let's do that. And there's a very famous quote by somebody somewhere who said, culture eats strategy, blah, blah, blah. I say they had food poisoning during the rest of the day. Do you know, the rest of the story? And so that, in my opinion, that putting security and acknowledging security as a bit of a people problem, not just a technology problem, is really what can change things in an organization. Now, my next demo is a tool that I really love. And the reason I love this tool is it's extremely simple to adopt. It's fairly straightforward in what it can do. But until the point that people discover it, nobody knows it exists and nobody knows to use it. But once they do, people love it. And I'll show you a quick demo. So this one is called Scorecard. And Scorecard is an open source. Again, all of the stuff that I'm going to show right now is fully open source. Nobody has to have any problems in terms of licensing these or making use of them. Scorecards are a tool that's maintained by the community at the OpenSSF. And Scorecard basically allows you to take any repo that's out there and give it a baseline in terms of security. Now, you might wonder what a baseline is. It is basically a simple score based on a number of parameters that Scorecard will analyze. Now, I'm going to take the risk of publicly shaming myself, and I'm going to hit my repo as an assessment for Scorecard. Now, what Scorecard basically does is it will take any repo that you give it, and then it will run these 35 or something different tests that are grouped into these, I think, 16 or 17 categories. I can't count. Maybe you can count later. But it will assess any open source code base for what are all potential problems that might exist, and it will give us a score for how good, or in my case, how bad a code base can be. So by, I don't know, CBSE standards, this is just pass. I don't know. But anyhow, the point is, this particular tool is aimed and designed at helping open source communities provide an assessment or get an assessment of how good or bad their code can be. It will check if your code has any binary artifacts that are embedded within it. It will check if you're following branch protection rules. It will check if you're doing code reviews regularly. It will check if contributors are from multiple different organizations. Now, I understand that some of these might not apply to you, and you have a way of excluding those assessments. But again, I see Scorecard not just as a way to assess my open source project, but also as a way to assess any tools that you want to adopt. Now, this is a publicly available database of many different projects out there. For example, this is Node.js. So if there are Node users here, this will give you a good idea of how good their code base is, just in terms of open source security parameters. People are probably familiar with TensorFlow. TensorFlow has a slightly better score than Node.js. So the way I recommend people consume scorecards is not just to create scores or assessments of your repos, but also of looking at other repos and saying, hey, can I determine if this is safe for my organization or not? Do you have a simple way of doing that? My bet is you don't. So I highly recommend starting to use Scorecard. It can integrate inside your repos as a GitHub Actions. So if you're in the business of doing GitHub Actions and things like that, I would recommend creating GitHub Actions and integrating Scorecards as a code scanning tool. The other thing I wanted to introduce, because we were speaking about open source, is this notion of supply chain security or software supply chain security. Now, I was particularly affected by this, sitting at the at the center of the Cloud Foundry community. There's tons and tons of projects within our community, and those projects in turn are consumed by big organizations, small organizations, service organizations, product organizations, governments and banks, and what have you. What happened was a very interesting incident struck the technology world about 4 years ago. We haven't forgotten about it. Most of us have recovered from it. But the idea is, because there was a vulnerability in one of the components that we were using, a bunch of our other projects got affected, and it led to an unknown number of problems out there. And so it became a question of you're using code, and this code that you're writing has some libraries that you work with. They have some dependencies that you also integrate with. And then this code gets built in an environment that's in the cloud somewhere. You don't know what. And then it gets packaged, and sometimes it gets packaged for specific environments, and then it gets shipped. Now, this is a very common workflow for all of us. Problem is, there's ways in which all of these different steps can create, issues. At times, you don't know who has written some of the images that you're using. How many times have you gone to Stack Overflow, copied a couple of lines, pasted it inside a Docker file that had references to some base images that you didn't know where they were from? Everybody has done it. Again, don't raise your hands. Your manager might be watching. There's problems that have happened because once you've created an image, because it was built, like the build process ran on an infrastructure that was compromised. People heard of the SolarWinds attack. Does it sound vaguely familiar? What they did was they had a build system that was on some shared cloud infrastructure. Another tenant on the same infrastructure shipped their code with some vulnerabilities that allowed some attackers to take control of the underlying infrastructure. And so every SolarWinds software build was infected through the underlying infrastructure of no fault of their own. And so after they shipped their software to like hundreds and thousands of hardware devices around the world, they then discovered that, the place where we built our software was not sanitized enough. So that's the problem. If you don't have a sterile build environment, chances are you can have problems. And you have no idea about what is being shipped, which is because of the original problems of copy pasting and just using random images and things like that. And there's very specific projects that are available in the world in open source for people to use and consume in order for you to be able to solve these three very specific problems. Cosign helps you identify with signatures many different things. Particularly, it attaches an identity to any artifact. Salsa prescribes how sterile you can make your build environment progressively. It has a level 0 to a level 4, and all of these 5 levels tell people, do these basic steps in order to go to the next level. Do these additional steps in order to go to the next level. And SBOM stands for Software Bill of Materials. Bill of Materials is a concept that we borrowed from the supply chain world, and it basically tells people exactly what's inside a build after you've built them. I might not have enough time to showcase all of these things on stage today, but if you're interested in exploring these further, please do reach out. I'll end with a quick demo on what Cosign is. What this basically does is it will create a pair of keys, and then it will do the same build process as before, but what it will do additionally is it will sign these builds. What a signature means is that so in this case, what will happen is it will upload the image that I built to a container registry. Everybody know what a container registry is? So if you use Docker Hub, that's the example that I'm using here. So the way images are deployed into production are, you write code, you build an image gets uploaded to a container registry, and then from the container registry, it gets deployed into production. So in the container registry, what this allows is for images to be signed and for those signs to live right next to the image itself. So for example, here, I am pushing this image, and along with that image, I am also pushing a signature. So once I push that signature here, so this last step just pushes a signature, and that signature will live along with that image. So what you can do with that is, let's say you have an admission controller sitting on your pipeline. You can say, hey, deploy this image if and only if it has a signature along with it. What you can also do is you can verify the signature. So this last step here is verifying the signature. So you can also run an additional cosign saying you take the public key of your build infrastructure that's only known to you, and you can verify before deployment whether or not this image was actually built where it is supposed to be built. On time, I finished all my 3 demos. I just have a thank you slide. Bear with me for 1 extra minute. So you might ask, Ram, all this is nice, but the big question that everybody asks is, can't I just use AI? There's this famous quote by somebody that said, I want AI to do my laundry and cleaning so I can do poetry and prose. And much like that, I think it's time for AI to do my security work so that I can continue to focus on code, which would be nice instead of Copilot and SourceGraph writing my code for me. But the answer to the question is, it's a very diplomatic answer, but the real answer is, I don't quite know myself. So yes, there's a lot of research that's going on. AI can barely write a letter to my mother. I don't know how long it will be before it can do some security stuff. Now, absolute last thing I promise is, there's a free course in security developed jointly by the Linux Foundation and the OpenSSF. So if there's one picture that I'll ask you to click today is not mine, but take a picture of that, scan it, get access to the free course. It covers a lot of the basics of security if you're interested in that topic. One of the ways that I find it most beneficial is as part of an onboarding exercise for anybody who joins new in the company. They can go through a security course, and it covers a lot of the fundamentals in much better language and ways than I could today. Anyhow, this is me on all social media. Don't hesitate to say hi. And that's my talk. Thank you so much for coming here today, staying after lunch, and after you got goodie bags. It's amazing to see the kind of events that the Kochi community is putting together. And it will always be a pleasure for me to come and speak. Thank you so much.
Awesome, awesome. Ram's talk was the whole package. It had a quirky title. He said the quiet things out loud, which we developers don't want our managers to know, right? And he even gave us a return gift, which is the free course, right? So after all of that, we of course have to give him a token of our appreciation. So I invite Humble to give a very small token of our appreciation to Ram.